ancient organisms that defy the imagination and push the limits of what we knew life was capable of. And we give them names accordingly, with names taken from history, from literature, and mythology. Leviathan is an ancient whale. Behemoth is a butterfly. In 1975, Dr. Doug Lawson named the largest flying organism and named it after the Aztec god of death. Death and rebirth and learning as well. Pretty much kind of the best name you can have for an extinct organism. And this was reported around the world in print, in radio, on television. It was met with the same excitement that you had for the discovery of eggs by the Mongolian expeditions. And then that was largely it. No real scientific description, no real technical naming, nothing for almost 50 years. It's one of the biggest teases we had in paleontology. And so today I'm addressing this issue. I'm going to discuss Quetzalcoatlus, the largest known flying organism. So apologies for those in the room. You just got that introduction again. I'm going to scoot into where I was in lecture to make up for time, but just a quick review. Quetzalcoatlus is a pterosaur, an ancient flying reptile, lived and died alongside the dinosaurs, and ginormous. Here's the skeleton shown at the Texas Memorial Museum in Austin, Texas. The thing is huge. It has a wingspan of about 10 meters, or 33 feet. By comparison, I have a wingspan of about 1.73 meters, or 5 feet 8 inches and a quarter. So a truly ginormous organism. We have trouble conceptualizing how this thing stood up, let alone how it flew. So let's just take a quick review, talk about pterosaurs. Now, any of you ever look at a piece of artwork showing some dinosaurs? Invariably, they'll just have kind of like a pterosaur off in the corner there. Just a bit of a set dressing there. Rarely are they kind of the main focus of the screen. That's usually like a dinosaur, like a T-Rex here, but always kind of there in the background. But pterosaurs were incredibly diverse and numerous during their time period, and they were found the world over, every single continent, including Antarctica. We have over 250 named species of these guys. You can pretty much think of them as being the birds and bats of the day. So pretty much anything that a bird or bat would do now, a pterosaur did during the Mesozoic era. So they lived and died along dinosaurs. They are our first bony organisms to learn how to fly. They're also the longest dominant flying organisms. So they ruled the sky longer than bats, birds, or insects had ruled the skies. They were dominant for the longest time. And of course, they made the largest flying organisms. And so I describe them as the most successful flying vertebrates of all times. One slight problem with that. They've done this the incredible disservice of dying out. And so whatever happened to the dinosaurs probably took out the pterosaurs as well, leaving no living representatives of them. So incredibly successful, but also incredibly dead. They're most commonly, they show up in textbooks as a bit of a comparison of convergent evolution. So flying organism has shown up 4 times: bugs, birds, bats, and pterosaurs. And pterosaurs are the only one to go extinct, but they've learned to fly in different ways from other organisms. So bats are going to fly using the fingers of their hand to hold out a membrane. Birds essentially used kind of their entire hands and wrists kind of fused together. Pterosaurs, flying reptiles, are pinky flyers. And so they learned to fly by taking their pinky and making it giant, stretching it out by extreme length, and from it stretching a membrane that would go to some place on their body. Now, people always kind of show this membrane they had on their wing as like leathery. No, these things are really complex. The inside, and this is a real specimen from Germany, of the pterosaur wing membrane has all these long struts that give it internal support so it could flap its wings without it fluttering in the breeze. But also we have other layers in there, like a whole bunch of blood vessels. I do wonder, like, what would happen if this ever got like a little cut? Would it just bleed out here? But this was a living tissue full of blood. And also our good friend the pterosaurs are fluffy. They are covered with a hair-like filament. It's not hair. There's a bit of a debate over what they are. But when we have really good preservation of pterosaurs, and this is a real specimen I've seen with my own eyes, they are covered with these kind of fluffy fibers coming out of them, which we call pycnofibers. So yeah, all of our pterosaurs would have been on the fluffy side. A little hard to think of. Yeah, they weren't really that scaly. They pretty much just had scales on their hands and feet. And so this guy, we see an amazing diversity of pterosaurs. This is a type of pterosaur, we call it a neurognathid or a frog-mouthed pterosaur. These were pretty much the equivalent of like a bat or a nighthawk or nightjar bird, or even some species of owls. This is a creature with huge eyes and a giant Pac-Man-like head that it would use to go and grab insects at night. And so we can see all these different pterosaurs that pretty much did things, hundreds of millions of years ago that we see in organisms today. So we have sort of a bat owl-like thing. This is Pteranodon, probably lived its life like a pelican. We also have various skimmers and dip feeders. Our most common pterosaurs we find near the ocean. We got kind of a seagull thing. But we have other examples of pterosaurs living out lifestyles we have today as well. This is Zungaripterus. I've always envisioned him as sort of similar to having a vulture lifestyle. This is Istiodactylus. It probably was similar to a bird of prey during his time period. We have things like storks and herons, more about them later. And even a pterosaur version of the flamingo. This is a filter-feeding pterosaur. And some weird ones as well. We have a pterosaur version of a spoonbill, of probably a parrot, and a few things we're not really sure what they did. This is another one relative to our parrot guy, but like God only knows how this thing lived its life. And it's not alone. We got this creature, and things that look like that. We have these things that, there's probably not equivalent of a bird or bat today doing. And yeah, that is a real thing as well. God only knows what it was doing with these crazy crests coming off of its head. And some things that just belong in your nightmares. So, yeah, I don't want you to be thinking of pterosaurs as just these group of extinct reptiles that, belong in a history book. These were the birds and bats of their day that lived out lifestyles like you'd find today. Anyway, that was over the 160 million years that pterosaurs ruled the skies. I, today, am going to be talking about the very, very end of the age of the dinosaurs. We're going to be talking about the latest and greatest of pterosaurs. Just talk about the pterosaurs that lived right before that meteorite impact and killed off all the dinosaurs and pterosaurs. So we're going to be seeing the youngest, the very last of those today. So this group of pterosaurs, the giants, we call the Ejdarchids. They belong to a family called the Ejdarchidae, and they are big. So, jump back to our good friend Quetzalcoatlus. I promised talking about him. Here's an artist's conception of him. This is done by the eminent Dr. Mark Whitten. If I don't poke out who did the artwork, it was probably done by Mark. He does a lot of great illustration of pterosaurs, especially of the Ejdarchids. So here is Quetzalcoatlus, and here is shown with Dr. Whitten for scale. Dr. Whitten just a bit taller than me. And also shown with a giraffe. Quetzalcoatlus was taller than a giraffe, and it could fly. It was also taller than a Tyrannosaurus rex, which they lived with. We find Quetzalcoatlus in West Texas, and we find pieces of Tyrannosaurus rex from the same place and time. So these guys lived with each other and interacted, which is largely probably for the inspiration for this scene from Prehistoric Planet 2. A really interesting scene in my opinion. If you watch this, it's a couple of Quetzalcoatluses fighting over a carcass with a Tyrannosaurus rex and winning. In the scene, the Quetzalcoatlus drive off the Tyrannosaurus rex. The only problem I have with this is they show Quetzalcoatlus as a scavenger. I kind of don't think they did that. I think in the scene, the Tyrannosaurus rex actually would wander off. Because if you take a look at Quetzalcoatlus, its torso was about as big as my torso. Those things would take 2 bites of something and be full and fly off, T-Rex just had to wait 5 minutes if you wanted to go eat that. But probably, yeah, these things were not were not scavengers in that way. So actually, I don't have a problem with that scene. Quetzalcoatlus also made a guest appearance in the most recent Jurassic World Dominion, in which it came in and destroyed a plane. Just kind of poked the engine and just crashed there. So, yeah, it's glad to see that Quetzalcoatlus is popular enough to show up in a Jurassic World movie there. But let's get back and talking about the big boys. So, yeah, they are huge. But it's not just our good friend from Texas, Quetzalcoatlus. There are 3 species and a couple other specimens of the truly big boys. And they're found all over the world. So we have Quetzalcoatlus from Texas. We got Rambourgiania. That's from Jordan, the Middle East. And we got Hexagopteryx from Romania. Also, well, actually from the part of Romania that's called Transylvania. So it's there's often descriptions of you compared it to Dracula there. And these guys are fun. They all kind of have sort of different body plan. Quetzalcoatlus seems kind of have an average build. Our good friend Rambourgiana seems a bit on the thinner side. And Hexagopteryx is our kind of chunky guy. So these are the biggest of our big guys. And it's just 3 species and a couple other specimens we have of them. Huge. But here's the problem. Remember, for 50 years, Quetzalcoatlus was held under wraps. It wasn't described. Very few people could see it there. And so the only thing we knew about this group was a couple of papers and these 2 guys. Now let me show you what we have of our other 2 giants. Here's our good friend Rambourgiania. It is known from one neck bone. That is it. And the neck bone isn't even complete. It's a part of a neck bone. Our other guy, Hexagopteryx, who is really fun. He lived on an island on which he was the top predator. The dinosaurs on the island were quite a bit smaller. You see this on islands a bunch of times. And so this guy probably was running around eating dinosaurs at the time, being the sort of top predator on this island. But all that we know of him is that we have part of his upper arm bone. We've got a bit of his skull, the back, and then part of the roof of his mouth, and 1 thigh bone. So, yeah, essentially kind of 3 or 4 pieces. And that's kind of it. So, yeah, our good friend Quetzalcoatlus, the big boy, the biggest of all these guys, and all the pieces it had were just held under lock and key for the longest time, the biggest mystery. And so we knew very, very little about this group because of that. And so I'll talk a bit more about going this forward for this guy. So these Darkids, it's not just the giants. We actually have about 15, 16 species of these total. It's a whole big diverse group. The big boys, they all belong to a part of that group. and they just lived at the very, very end of the time of the dinosaurs. So our good friend the Azhdarchids, it's not just the big boys. These guys are all pretty big, but they're just not huge. But it's a very, very diverse group that lived at the end of the time of the dinosaurs. So, So the Azhdarchids, really kind of interesting dynamic organisms. They've gone in and inspired some really kind of interesting artwork, including this meme of scary pterosaurs. And so if you can go online, you see a bunch of artwork which pretty much show, these pterosaurs as scary beasts, and they really kind of have sort of a Slender Man vibe to them. And so it's become its whole meme there of what these guys would have looked like. And you got to imagine if you came across one of these giant organisms, you would be kind of, nervous around them. It's a creature you wouldn't want to meet in a dark alley. There would have to be a pretty big alley to fit them in. So, second greatest question I have on these guys is, what did they do? And our opinions of how these guys lived have changed quite a bit over the years. Initially, it was suggested they ate dead animals, they ate carrion. It's even been suggested these guys might have even been flightless. They were so big that they couldn't fly. It's also been suggested that they ate invertebrates like, clams and insects. It's also been suggested that they fed by flying over and dipping their head down the water to snatch up fish. They've been compared to herons or storks that would just go and sort of pick their food from different bodies of water there. So there'd also be waders, or even just ones that would swim around in bodies of water to food. Also been put forward as carnivores in and of themselves, going down and pretty much snapping out anything living that could fit down its gullet. And in recent years, even suggested just to be kind of generalist or kind of omnivores, pretty much eating just about anything that it could fit down its gullet. So my take on the matter is, what does a pterosaur with a 33-foot wingspan that was taller than a giraffe eat? Anything it wanted to. So we kind of today, most recently, kind of view these guys as somewhat similar to storks, especially more terrestrial ones. I might want to look up the marabou stork as an example thereof. That's kind of our latest theory of how these guys lived. So let's actually talk about Quetzalcoatlus. So first pieces were discovered in 1971 by Doug Lawson when he was a grad student at University of Texas at Austin, and reported in 1975 in an issue of Science. He would later go on and name it a few weeks later in the same journal, give it a name, which became problematic in that he described the organism and named it in two different papers, which technically was not the way you would go about naming a valid species. And so some years later, going back to 2017, me and some colleagues went in and wrote to the International Commission on Zoological Nomenclature, asking them to make Dr. Lawson's name valid here, and address the problem of it being named and described in two different papers. So we had to go back and make sure that the name was official there, and so we managed to sort that out. Dr. Lawson, he named and described the initial material, but the vast majority of the material, and there are almost 300 over 200 specimens that we know of it, for the longest time just were not described. And over this time, it was worked on by the eminent Dr. Juan Langston, professor at University of Texas at Austin and Dr. Lawson's master's advisor. And he worked on this specimen for pretty much the last 40 years of his life and passed away without finishing the project. When yeah, when he passed away, we went and looked through all of his files in his office and all of his paperwork, and the only thing we could ever find was about 15 pages of double-spaced typescript describing some of the neck bones, and that was it. And so, this project at this point in time had been around 40 years, and there was nothing to show for it. And so, what the staff at the University of Texas at Austin did is they assembled a team of researchers to come by and to describe it. And so this culminated in a monograph, sometimes called a monstergraph, published in the Journal of Vertebrate Paleontology that came out in 2021. And finally saw the light of day. And so now everyone can go, and it's freely online, and you can go and download this or find a copy of this to read all about it. For this project, they assembled a team of experts, with me there shown in the back, with people who work on aeronautics, who work on functional anatomy. We even had an artist work with this. And I came in to describe the anatomy and work on the evolutionary relationships. So we assembled a team to work on it. A lot of the artwork you'll see for this was done by John Conway, shown here on the left, the only attractive member of the group, who helped with a few of the chapters and did the cover art for this publication there. So, what can I tell you about Quetzalcoatlus? One, I can tell you that it's not just one pterosaur. One of the things that came out of this research was that this part of West Texas, at the very, very end of the age of dinosaurs, actually had quite a few pterosaur species there, and a lot of areas with these. And so, in this part of the Big Bend National Park, where we find all these pterosaur remains, we have found pterosaurs at about 5 different locations. And we find them in different types of rock, in different ancient sediments. So we find pterosaurs in this area, 5 different places, and sandstones that were laid down in riverbeds. We find them in these sort of abandoned oxbow lakes. We also find them in these flood deposits that were up on the floodplain. So 3 different ancient environments that have 3 different pterosaurs found in them. So the pterosaurs we find, the big boy, the one that everyone talks about, we pretty much only know from a wing. There is shown at the Vertebrate Paleontology Laboratory in Austin. That is largely all we have of the big boy. He is gigantic, but there's not that much known about him, just this huge wing. However, and so he was found in the bed of a river. But he's not the only thing we find in riverbeds. Other places throughout Big Bend, we have pterosaurs. Oh, and this is the parts we have of them. It's pretty much just his left wing there. But we have other pterosaurs found in these riverbeds in 4 localities in general. And all of the ones that we find in these riverbeds were actually pretty big. Some of them were quite gigantic, other ones were at least a healthy size. So take for example, this is part of the forearm of a pterosaur, also found in a riverbed. This was found within inches of the end of the age of dinosaurs, and so as far as we can tell, this is the youngest pterosaur ever found, the last one we know of before the Great Extinction Event. But we have other giants from these areas. We have a big leg bone also found in these sandstones, and a other neck vertebrae found in these riverbeds. And so, in this environment, the strange thing is that we find different pterosaurs in different ancient environments. And so in the rivers, we find the giant ones. And some of those you can be directly referred to our big guy, Quetzalcoatlus northrop is the species name. Other ones sort of more indirectly. So that's what we find in the sandstones. Now, in our little ancient oxbow lakes, we find a smaller example. And this we decided was going to be a new species. We named it Quetzalcoatlus lawsoni after the discoverer Doug Lawson. And it's from this species, about half the size of the big one, that we have hundreds of specimens. And these are predominantly, well, they're essentially found from one locality, from one place, but at many, many, many different horizons. And there are lots of these. And we find them all together in these areas that had to be dug up as quarries. And so there were a lot of them in these one area. These were a group of pterosaurs that lived with each other. It was a flock of pterosaurs that were in this area for one particular reason or other. And from this guy, we know the most we can about their anatomy. We pretty much have every bit of this species except for, some of the ribs, the backbone, the tail, and the back of the head. That's about it. And so it's not the big guy, but it's a close relative, and it's just an amazing amount of material, and from this we can know so much more about their anatomy. These guys, we think that they, based on the eminent work of one of our co-authors, Tom Lehman, these guys were like herons. They were kind of similar to birds that lived in these little lakes that would eat all these different types of invertebrates, and so kind of live more like herons. Our big guy, we think, are more probably terrestrial, lived up on land, and probably more like storks, kind of more like omnivorous there. But that's not the only pterosaurs we have there. We found also a third species. Now this specimen here, this is shown the beak of it. It was first shown in a book by the eminent pterosaur researcher Peter Vellenhofer. We ended up naming the species after him. And for the longest time, it was a big mystery of what this thing was. And we had a bunch of different ideas of what it was. It's found in the same area as our small species of Quetzalcoatlus, but a lot lower down. And there's been a bunch of guesses of what this thing is. It's thought to previously be one of our Quetzalcoatlus species, the small ones. It's been suggested, one's just called a short-faced animal. It's suggested to be a type of pterosaur that we think were like our parrots, the tapajarids. Also, thought to be related to one of our other crazy specimens, species with these weird crests on them. It's been suggested to be a lot of different things. Now, this is largely because when it was shown in Peter Vellenhofer's book, he just showed the bill of it, and the neck vertebrae were not shown as well. This guy has a very, very long neck, like the other Asdarchids we have. They have very long skulls and they have very, very long necks, incredibly long necks. And so if you consider the neck, it's really quite obvious that this is another one of our Asdarchids, but a much, much smaller guy. So yeah, it was a big mystery what this was until we found out, until we described the associated neck. And this is part of the same organism. We have pictures of Dr. Langston digging up the specimen, finding it there, and even, a picture in his notes of this, neck bones being right there. So we're sure this is from the same animal, and from this we can tell this is a new species and different from Quetzalcoatlus. So, but that's not it for pterosaurs. Those are the only 3 species we named out from there. There's other material found in other oxbow lakes, but it's actually not that great preserved, so who knows who that belongs to. Unsurprisingly, the pterosaurs we find here that were deposited when the rivers flooded over their banks are not in great shape, and so we have some pterosaurs. They pretty much were destroyed by floods, but also deposited there, including a very small specimen. Unfortunately, incredibly poorly preserved. But not the only thing out there. In our flood deposits, we also have some big specimens as well. So it's the strangest thing. So here is pretty much all the pterosaurs we find in Big Bend. We have our giant Quetzalcoatlus northopi. We have its smaller relative Quetzalcoatlus lawsoni, also pretty big guy. Even smaller, we got our third species, Valenhopterus. And we also have a pterosaur, which would have had about the same wingspan as I would have had. So, but so poorly preserved, we can't tell if it's a new species or just a juvenile. So, out in this part of Big Bend, we have at least 3, maybe 4 species of pterosaurs, going everything from pterosaur about my size to the largest thing ever known to fly. And this is important, but because it goes in to help answer a big question we have for pterosaurs, but also dinosaurs in general. And the question is, when the big extinction event happened, when dinosaurs died out and pterosaurs died out, were pterosaurs doing well, or were they kind of on their way out as well? My main part of the project I did was to figure out the evolution of these guys, largely because a lot of organisms have been suggested to be related to our big group, the Ashdarchids, from all over pterosaurs. It's a lot of things have been suggested to be from our group of big boys there. And looking at these anything but the ones that live at the very end of the age of dinosaurs, they're going to be something else here, which is really quite important because if you find these big boys, all of our named species are from the very, very end of the age of dinosaurs. So they are just known from, the late Cretaceous, the last bit of the last period of the age of dinosaurs. But you have, pterosaurs specimens going back to the end of the Jurassic period, almost 90 million years previously, suggested to be these guys. And if that were true, it would have made for a much different view of the evolution of pterosaurs. Because if our group of Ashdarchids, which the only species we have at the very end, actually started back 90 million years ahead of time, then that would mean we had this huge burst of evolution a long time ago, and then just over time we would just have fewer and fewer and fewer groups appear, really suggesting a evolutionary history which had this big burst of evolution, and then this pterosaurs just were slowly dying out for the entire Cretaceous period for the last 90 million years. And so it was really quite important to figure out whether those specimens belong to it or not. They don't. As Ashdarchids, they only lived at the tail end of the pterosaurs. And why is this important? Because it has been suggested that that was the case. That pterosaurs throughout the entire Cretaceous period were on their way out. This has been suggested before, but it was most put forward in a paper put out in 2006, which was looking at the diversity of pterosaurs versus birds. And in their study of pterosaurs, they suggested that at the very beginning of the Cretaceous period, you had this amazing diversity of pterosaurs, and just slowly over time, you get fewer and fewer and fewer species. Also, at the same time, you start getting bigger and bigger ones, ending with the giant Ashdarchid pterosaurs. So, their hypothesis was once birds appeared, they started to compete with pterosaurs, and so the pterosaurs, wouldn't compete with the birds. They instead grew larger and had fewer species over time. So that their scenario was that birds pretty much drove pterosaurs to the brink of extinction, and then the meteorite finished them off. Now, part of this, and the biggest support they had for it, was that our largest pterosaurs lived at the very, very end of the age of dinosaurs, and they were huge. And so our study going in there and finding out that, yeah, the largest pterosaurs did live at the end, but it was actually really quite a diverse time period that had pterosaurs of all number of shapes and sizes. So in 2018 with a colleague, we've gone in and we looked at the diversity of pterosaur over time, especially at the very, very end of the age of dinosaurs, and found that there's actually quite a lot of species at the in the late Cretaceous and a decent number at the very, very end. So we have a whole bunch of groups making the late Cretaceous, and we have actually a few species coming in at the very, very end of the age of dinosaurs. So add to this our work in Texas on Quetzalcoatlus. It's not just one species, it's a whole bunch of species of a bunch of different shapes and sizes. Gives us a much different picture of what was happening to pterosaurs at the very end of the age of dinosaurs. And so we've gone in and we've made a new picture of how pterosaurs were doing over time. And it is true that in the sort of early Cretaceous, there we have a whole bunch of species. This is largely due to we have a lot of pterosaur deposits at that time, a lot of good formations to pick up these guys. But once we pretty much get to the late Cretaceous, things level off as far as number of species. And it's the late Cretaceous had these pretty much the second highest number of pterosaurs around, tied with the late Jurassic. So the number of pterosaurs we had, it wasn't the most number, but it was the second highest number of pterosaurs we'd have around. And even if we go to the very, very, very end of the age of pterosaurs, we see there is a slight spike in number of species. So at the end of the age of dinosaurs, pterosaurs, not only were they getting bigger, they were increasing in number. Yes, we had huge ones. We also had pterosaurs that were my size. So the view we now have of the last pterosaurs, right before they died out, is that they were doing quite well. We have a number of species, a number of different sizes on land and the sea. They were doing quite well, and they just happened to be taken out by the same cause, probably meteorite, that killed off the dinosaurs as well. So as the sun sets on pterosaurs and Quetzalcoatlus in general, this crazy organism, this